All right, now we're going to talk about multiplying and dividing rational expressions. Now, before we start working with letters and things like that, I want us to go back to what we already know about plain old fractions, just numbers. And we'll refresh our rules, and then we'll apply those same rules to bigger and better things. So let's start off with just simplifying fractions. Let's say that we had 3 over 6 and we wanted to simplify that. Well, normally, because we've worked with fractions and things for so long, we really wouldn't even think about it anymore. We would just say, oh, well, that is 1/2 because what? 3 goes into 3 one time, 3 goes into 6 two times, so that would be 1/2, right? Well, now, that's great and fine. But we also really need to focus on what's going on. Let's do this the proper way, the way we were first taught how to do this. Let's say we have the number 3 here. Could we rewrite 3 as 1 times 3? Absolutely. And 6 we could rewrite as 2 times 3. Now, what's really happening whenever we reduce or simplify fractions is that we are canceling out common factors top and bottom. Technically, you're not really canceling either, but anything over itself is 1. So 3 over 3 becomes a big old 1. And all we have left here is 1/2. So that's what's really happening whenever we simplify fractions. I want us to keep that in mind because we're going to apply that when it comes to working with rationals. Now, with something like 3/6, it's not bad. We can do that in our head pretty easily. But something like 1260 over 1998, we're going to have to really do a bunch of dividing out top and bottom in order to get that. Now, another way that we could do it is we could completely factor the top and the bottom. Now, when I say completely factor, let's look at this using that old factor tree. If I use an old-fashioned factor tree, then let's say I need two things that multiply together to get 1260. So how about 2, oops, again my pen is not working very well, 2, there we go, 2 times 630. Okay, 2 is prime, but we can break down 630 some more. How about 2 times 315? Well, again, 2 is prime, but we can think of two things that multiply together to get 315. Because I know 5 will go into it. 5 times 63 will give us 315. Now, 5 is prime, but 63 is not. 63 would be 7 times 9. 7 is prime, but 9 is not. 9 would be 3 times 3. So if I were to rewrite 1260 using only its prime factors, that would be 2 times 2 times 5 times 7 times 3 times 3. And now let's do the exact same thing with the 1998. So 1998, let's see, 2 times 999 will give us 1998. And 999, let's see, 3 will go into that 333 times. And 333, well, that would be 3 times 111. And 111 is 3 times 37. Now, those are prime. So I could rewrite 1998 as 2 times 3 times 3 times 3 times 37. Now, we can cancel common factors on top and bottom. So look, we've got a common 2's on top and bottom. That really becomes a 1. We've also got here a set of 3's on top and bottom and another set of 3's on top and bottom. Now nothing else will cancel out, so now we can just multiply what's left over. 2 times 5 times 7 would be 70, and 3 times 37 would be 111. This is exactly what we're going to be doing when we work with true rational expressions.